Hello everyone, thanks for joining my presentation. My name is Haikun Huang, a postdoc from George Mason University. Today I'm going to present our paper, Interactive Design of Gallery Walls via Mixed Reality. This paper devises an intuitive tool to help the non-professionals for the gallery wall design via the mixed reality headset. Gallery walls are commonly used for decorating indoor spaces. Creating a gallery wall involves selecting a number of compatible art items and arranging them aesthetically, which could be tedious and non-intuitive. In this work, we devise a mixed reality-based suggestive interface to facilitate the design process. In this project, we have the following major contributions. Based on the interviews with the Wayfair professional designers, we devised a computational approach for facilitating and automating the design of gallery walls, which enables a novel mixed reality interactive design tool. We demonstrate how mixed reality technology, which bridges the gap between the real-world science knowledge and design suggestions, compute in a virtual setting, which can be adapted for the interior design. In our case, we particularly demonstrate how such an approach can be applied for designing gallery walls. We conduct experiments to evaluate the user experience and performance of using our novel tool for gallery wall design. Here is the overview of our tool. It consists of two major components: a suggestion engine for generating design suggestions, and a user interface for customizing the design. Our tool takes a database of walled art items and a wall as input. We start by suggesting a focal art item based on its color compatibility with the wall color. The user may either manually add the other walled art item or apply a template to automatically generate an initial design. Then, the user interactively refines the design with the help of our suggestion engine. The database contains 12,000 walled art items created by the Wayfair professional artists. Each walled art item is annotated with its embedding vector extracted from a convolutional neural network, and a number of tags, as well as its 5 dominant colors. Based on the wall color, a neighbor color is selected from the HSV circular color space. The complementary color of the neighbor color is also selected. Our system then recommends a set of a candidate focal art item whose colors are compatible with the free color palette of the wall. Our approach computes the compatibility scores for the all art item in the database. The top 20 art items are retrieved and displayed in order of the compatibility scores, with the highest scoring item shown first. After selecting a focal item, the user can apply a template to quickly populate a gallery wall design based on the color, style, and spatial attributes. The compatibility score is computed for each art item in the database. The user interface displays the top 20 art items sorted in the descending order of their compatibility scores as the LS3 art item suggestions. We provide a number of preset templates that the user can apply to synthesize a gallery wall design based on the selected focal item. The blue item represents the focal item. The colored item represents the groups of 2 or 3 auxiliary items. Our tool automatically adds a group of 2 or 3 auxiliary items, which are compatible with the focal item, to the correct design. A group of auxiliary items are symmetry about the focal item. The user can also modify the initial design interactively. To keep the design compact, our system snaps and aligns the art item after every user interaction. Here, we present the results of our user study. The first group was recruited to evaluate the user experience of designing a gallery wall using our mixed reality interface based on the Major League 1 wheels using the 2D interface on a desktop. We recruited 18 participants, aged between 20 to 45. All participants did not have experience using the Major League 1 headset. Each participant designed 2 gallery walls under condition mixed reality and condition 2D interface. The second group was recruited to evaluate the user experience of designing a gallery wall with and without the template functionalities. We recruit 34 participants, aged between 19 to 24. Each participant designed 2 gallery walls under condition with and without template. Here is the user interface of our tool in mixed reality. Before each task, we briefed and trained the participants in creating a gallery wall design using our tool. We asked the participants to follow a 5 mini tutorials which guide him or her how to use our tool to create a gallery wall design step by step. We asked the participants to create a gallery wall design under the different conditions. The goal of each task was to design a gallery wall for a living room with a pale gray wall and a blue sofa. Here are some designs created by the participants. We check the participants' performance in finishing the tasks under each given condition. Under the mixed reality condition, the participants made fewer kicks and movements compared to the 2D condition. We also check the usage of the suggestions. The results shows that the participants removed about 25% of the items created by the templates. On the other hand, they resized only 10% of the items created by the templates. The results here shows that about 60 to 18% of the items used in the final design, which are chosen from the top 20 items suggested by the suggestion engine according to the criteria specified by the participants. The selected item ranked around 8 to 10 in the item menu. The participants traded to choose the item that matched their specified criteria, but not in a very strict sense. We proposed the novel mixed reality-based interactive design tool for gallery wall design. By overlaying a virtual gallery on a real wall, our tool allows users to directly visualize their design in the real wall as an integrated part of the creative process. Our suggestive engine facilitates the user in collecting compatible art items for creating their gallery walls. We use the Major League 1 headset for experimenting with our tool. The hardware still has a limitation for consumer use. For example, the field of view is still a little bit narrow for the user to see the overall design and the user interface at once. The user must look around to see the different things, which is inconvenient. It could be tiring to use the handheld controller for the 3D interaction in the 3D space for a long time. In this work, we only focus on a subset of interior design, namely gallery wall designs. In the future, it would be interesting to extend our mixed reality design tool to also consider the context of the 3D scenes to facilitate other interior design tasks, such as suggesting furniture placement. With the advance of artificial intelligence and the natural language processing techniques, we hope that such techniques can be adapted in a mixed reality for enabling the natural and convenient user interaction experience in the designing process. For example, it would be very helpful if a mixed reality interval design application could understand the voice commands from the user to decorate a space. It will minimize the needs for the manual input. With such advance, using a mixed reality application for interval design will be as natural as talking to an interval designer who can visualize the design for their client through the mixed reality. We believe this is an exciting goal for enabling the human-AI collaboration in the future. For commercial purposes, art items could be further annotated with extra text, such their prices, frequencies of being viewed, and frequencies of being selected. Incorporating such additional text could provide more discernible item recommendations while the user are creating their gallery wall. Here, we present a novel tool for gallery wall design via the mixed reality. This is the end of my presentation. Thank you.